Good morning, students. Today we are start with our last sessions. We continue with the block cipher principles. Is a part of encryption and decryption standards and various method of substitutions and transportation. Block cipher principles are, I repeat, mostly the symmetric block cipher are based on a Fischl Cipher structure. Needed scene must be able to decrypt ciphertext to recover message efficiently. Block cipher look like an extremely large substitutions would need table of 2:64 entries for a 64-bit block. Instead, create from smaller building block using idea of product cipher. Most modern block encryption algorithms use the Fischl structure. So Horst Fischl was a leader of the IBM team that worked in late 1960 on Lucifer. He devised the so-called Fischl Cipher. The Fischl Cipher is a work on encryption and decryption standard from since so many years with IBM, and he researched and found a few encryption algorithm for security. It's a mainly area of research is information and network security. How to encrypt the text, how to secure our data. This is the main research part. Now, Fischl Cipher structure. The Horst Fischl devised the Fischl Cipher is based on concept of invertible product cipher. Partition input block into two halves, process of multiple round, perform substitution on left data half based on down function of right half and sub key. Here we are using a sub key. The main key is the second portions we are provided by the security third parties. It's called as a sub key. Then have a permutation swapping halves. So the swapping facility also available in each permutations. Implementation, channel substitution, permutation, network concepts. The Fischl Cipher structures. You can see here the plain text of 2 bits and ciphertext is converted into 2 bits. The number of rounds are there, number of keys are there, number of permutations and round are there. The each iterations have a 1/2. The sub key is used here. We can also see the Fischl structure is considered as F. Each and every round you can proceed the encryptions by using particular substitution and transposition method as per defined by scientist Fischl. PT of the block length 2W bits and key K is given as a IP to the encryption algorithm. The block is divided into 2 halves. 2 halves pass through n rounds. Each round I has an input as a LI1 and RI1 derived from previous round, as well as sub key KI derived from the overall K. Here we see the equations Li is equal to Ri minus 1, Ri is equal to Li minus 1 plus F under bracket Ri minus 1 comma Ki bracket close. Substitution on left half of the data. Here we can also see the equations. The permutation consists of interchange of 2 half of data. This is a particular form of substitution. Permutation network is defined as a SPN proposed by Shannon. Fischl Cipher encryption and decryptions. Same here, you can see the n number of rounds, but here we are follow the Shannon's equations and the Fischl Cipher encryption. Here we can see the input and output procedures where the various permutations, and we need to follow the equations is given by the Fischl. Fischl Cipher design principles. First is a block size, you already know, key size, number of round, sub key generations, round function. Here we see the block size is nothing but to increase the size improves security but slow cipher. Then next, the key size. What is key size? Is increased size improves security, make exhaustive key search harder but may slows up. Number of rounds is increasing number of improved security but slow cipher. The number of round increase, but here the entire procedure become a slow. Sub-key generation, greater complexity can make analysis harder but slow cipher. Round function is a greater complexity can make analysis harder but slow cipher. Block size in part of security, the large block means a greater security, 64 bits. Key size 56 to 128 bits. Number of rounds, a single round offer inadequate security. A typical size is 60 rounds. Sub-key generation algorithm, the greater complexity should lead to greater difficulty of crypto analysis. Now round function, again greater complexity, generally means a greater resistance to crypto analysis. Average time required for exhaustive key search. Here you see the various key size is 32, 56, 128 and 168. The number of alternative keys and time required at 10⁶ decryption per millisecond. Here we can see the for key size 32 bit, we can take a time to 2.15 milliseconds. If key size is 56 bits, then it can take 10 hours. For 128 bit key size, can say 5.4 into 10⁸ years, and for 168 bits you can see 5.9 into 10⁻30 years. This is the average time required for executive key search. That means the number of bits increasingly the time. Data encryption standards, the most widely used block cipher in the world, encrypts 64-bit data using 56-bit key. As widespread use has become considerable controversy over its security. The data encryption standard is a symmetric key block cipher published by the National Institute of Standards and Technology. The short form is NIST. DES history. IBM developed Fiscal Cipher by team lead by Fischl. It used 64-bit data blocks, then redeveloped as a commercial cipher with input from NSA and others. In 1973, NBS issued request for proposal for a national cipher standard. IBM submitted their revised Lucifer, which was eventually accepted as the DES. This is all about the history, the who's developed, how many bits key the block used, how it's developed, how it's redeveloped. In 1973, you can see the NBS issued request for proposal. They need to submit the proposal, then it's approval, then once again it submitted the revised Lucifer. That means this is all about the history of DES. Then the encryption process in DES is made of two permutation P box, which we call initial and final permutations, and 16 Fischl rounds. Here we can see the key length is 64 bits, 56 per 8 bit considered as a parity bits. 8 bit are used for parity check. What is that? Possible reason to make it 256 times less secure against executive search. How secure is DES? This is an important question. In 1998, 150 key dollar machine can break the key in 5 days. For add security, triple DES is 256 more secure. Security analysis of DES, key length, why 56 bits we are using here. In the DES specification, the key length is 64 bit, 8 bit in each byte. The 8th bit is the parity check bit. Here you can see example in figure also. Here you see the first 7 bits is considered the 1 to 8, and next 7 bit is considered the 5, 7, 5, 5, 9, 6, 1, 6, 2, 6, 3 and 6, 4. This is nothing but just the key length. Here we can mention the why we use 56 bits and why we use 8 bits in each bit. The 8 bit is a parity check bits. DES features, the block size 64 you already know, key size 56 bits, number of rounds 16, 60 intermediary key each 48 bits. The plain text of 68 bits, we can apply DES, then output 64-bit ciphertext in which we can use the key of 56 bit. 8 bit considered as a parity bits. DES, this is all about the 60 round of permutation and substitutions. Plain text, we can initialize first, then round 1, 2, and number of round. Each round has a key, apply the 56 bits, then termination of entire process and rounds, and we can get the output as a ciphertext. DES is a 64-bit block cipher. Both plain text and ciphertext are 64-bit wide. The key is 64-bit wide, but every 8 bit is a parity bit. This is a repeat wielding a 56-bit key. General structure of DES. Here we can see the 64-bit ciphertext round the same as the above figure. Here we see the key 1, K1, K2 and K16. There are 16 rounds are there. Round key generation, we can use the key 48 bits, all about the 56-bit cipher key, 8 bit considered as a parity check. Then process start with input 64-bit plain text, then initial permutations, then we can apply round 1 by using key 1, 48-bit, round 2 and round 60. Up to round 60 we can use the K16 is a key 48-bit, and then finally permutations, and you can get output as a 64-bit ciphertext. Initialization process, the plain text, initial permutations, then right half and left half. We can apply the number of round. There are 60 round. You can also apply 48-bit keys, 8-bit considered as a parity, and you can get initialize the entire process. This is the steps you must memorize this. This is also important in GTU examination. Then termination process, the after round initialization, we can apply the multiple round. There are 16, number of keys used 48 bits, right half, left half, then reverse initial permutation, and you can get a ciphertext. This is our output. This is a general depiction of DES encryption algorithm. Here we are seeing the same process. There are 60 round initial permutations. Before that we can initialize the entire process. 32-bit swapping is a new thing. Inverse initial permutation. We are also seeing in the last topic. Here we can see the K1 to K16, the number of keys, permutation choices, left circular shift, and permutation choice 1. You can analyze the entire process, the 64-bit plain text converted into ciphertext by using DES algorithm. You can memorize only one thing, the 48B we can use for key generation technique, and 8-bit as a parity. Before that, you can also analyze the initialization process and permutation rounds at every steps. Then we can also provide a swapping of number of bits for security. Initial permutations figure out. Here you can see the permutation process, the basic graph. You can also get idea to how it's work and how to lengthy this matrix of the permutation process. DES subkey generation process. Here we see key with parity bit 64 bits, the parity drop, then cipher key 56 bit, 28 bits, shift left, then we can comparison P box and get process. Expansion of P box. Here we see the Ri-1 is a 32-bit input, Ki is a 48-bit key. We first need to expand Ri-1 to 48 bits. This figure is show out the 48-bit output from the 2-bit input. Here we can see the process of expansion permutation. Continue with the same topic. Although the relationship between the input and output can be defined mathematically, DES uses below table to define this. This is, here we can see the P box, the expansion P box table. This is output we can get generated from the initial permutations and a 64-bit parity check. Now we are continuing with after some time we can take a next session tomorrow.